Okay, Bismillah ar-Rahman ar-Rahim. We'll do the last part of this section, 2.4, Intermediate Value Theorem. So what we have, Intermediate Value Theorem, this is the theorem. Suppose that f is continuous on the closed interval, be careful. Let n be any number between f of a and f of b. I have, this is f of a, and this is f of b, and have this is n. So this is the point a and f of a. This is the point b and f of b. The question is, can you connect, if the function is continuous in the closed interval, can you go from there to there without crossing n? Impossible. So for any n between f of a and f of b, where f of a not equal to f of b, there exists a number c, so that f of c is equal to n. There exists a number c in this this open interval, so that f of c equal n. By the way, you can have more than one point, more than one c. We can have this, but at least one. For sure, there should be one. Actually, more than that, that the value can be taken in once or more than once. Huh? Okay. So the idea, the graph of a continuous function in a closed interval cannot have a break over that interval. Okay, that will lead us to what will happen if I have f of a. I assume here f of a. This is a. I have a and b. This is b. So f of a is here and f of b is there. Can I connect f of this point to this point if I have a continuous function over the closed interval without crossing the x-axis? Impossible. So it says if f is continuous in the closed interval, f of a and f of 0 are non-zero and have opposite signs. This is the main point. They have different signs. One of them is positive, the other is negative. Then there is at least one solution of this, because if c is a 0 here, f of c equals 0, and c is a solution of this equation, f of x equals 0. So it means I can show there is a root between two values without solving the equation. Assume I have this, I want to check. So let me take f of x. This is my f of x. I will check f of 1. I need to check positive or negative. That's my concern. Plus 3 minus 2. This is negative 2 plus 1. This is negative. F of 2. It will be 4 times 8, 32. Minus 6 minus 24. Plus 6 minus 2. Very clear it's positive. So, by the way, here I need to check if is continuous. By the way, it's continuous everywhere. Between 1 and 2. So, there exists C belongs to this interval, 1 and 2, such that f of c equals 0. There is a root between 1 and 2. So we prove this. Be careful. I need to find the root of x equals 0. So now this is, I cannot do it. I cannot deal with it. I need first to make it equal 0. So I will take minus 1 and x, 1 minus x, I take to this side. So now I call this my f of x. Now I will check. F is continuous in the closed interval, for sure. F at 0, 0, minus 1 plus 0, that will be minus 1, negative. F at 1, it will be 1 minus 1 plus 1, positive. So there is a root of this equation. So there exists a C, belongs to this interval, such that f of c equals 0. F of c equals 0 means what? Cube root of c minus 1 plus c equals 0, which means what? Which means square root of c equal 1 minus c, which is the same equation. So there is a root for this differential equation, this equation, not differential equation. Okay. Also, I can do it to check if two functions intersect or not. Because what's the meaning of intersection? Means f of x equal g of x. Means x to the power 4. And I will use the same trick. I need it equal to 0. So I'll take 1 to the other side. So I have f of x minus g of x equals 0. I call this capital H of x. So my capital H of x in this case will be x to the power 4 minus 5x cubed minus 2x cubed plus 4x plus 6. Am I right? Yeah. That will be x to the power 4 minus 7x cubed. Yeah. Plus 4x plus 6. So I check h at 1. It will be what? 1 minus 7 plus 4 plus 6, which is positive. H at 2, it will be what? 2 to the power 4, which is 16, minus 7 times 8, which is minus 56, plus 8 plus 6, which is very clear negative. So there exists a root C in this interval, such that what? Such that h of x equals 0. H of C equals 0. If h of x equals 0, means f of C equals C. And they intersect, and that's it. So we prove this. Yeah, I think it's a very clear, topic. Yeah, I will do this later because it's a little bit confusing. So I'll do it at the end. Okay, I have x cubed minus x. So this is my f of x. X cubed minus x minus 2 plus the square root of x. This is equal to 0. Oh, so this is the way they do it in the multiple choice. They give you intervals. They wanted to check. Okay. F of 1, that will be what? 1 minus 1 minus 2 plus 0. So it is what? Minus 2, negative. F of 2, it will be 8 minus 2 minus 2 plus the root of 2. So very clear, it's positive. So we have a root here. F of 0, let me check it. It will be 0 minus 0 minus 2 plus 0, which is minus 2, negative. So this with this, we get no conclusion. F of 3, let's just check them one by one. F of 3, 8 minus 2 minus 2 plus the square root of 2. This is positive, very clear. So this with this will give me nothing. F of 4, yeah, it will be 64 minus 4 minus 2 plus 2. So it's positive. So this with this will give me nothing. And actually this with this, both are positive, will give me nothing. So this is the only one. Using intermediate to show this has a root in this interval. The same idea. So it is my f of x. X plus the square root of x minus 4 plus x cubed equal to 0. So I check f of 1. 1 plus 1 minus 4 plus 1. This is negative. F of 2. I have 2 plus the square root of 2 minus 4 plus 8. So that will make it positive. So this is correct. F of 0. I have 0, 0 minus 4. Negative. 0 and 1 give me nothing. F of 3. Yeah, that will make it very clear. Big number. Plus 27. That will be positive. So 2 and 3 will give me nothing. F of 4, for sure it will be positive because 64. F of 5, for sure positive. So for sure all of these are wrong. So this is my correct answer. You should get only one answer. Calculate the existence of a root for this equation. Plus 2 equals 0. So this is my f of x. Check f of 1. 1 minus 2 plus 2, which is positive. F of 2, it will be 8. Wait a minute. X cubed minus 2x minus 2, sorry. This is minus 2. Yeah. So this is 1 minus 2 minus 2, negative. F of 2, it will be 8 minus 4 minus 2. This is positive, so this is okay. Be careful with calculation. F of 0 minus 2, negative. This with this give me nothing. Check f of minus 3. Yeah, check different values. Okay, that will be what? Minus 27 plus 6 minus 2, negative. F of minus 2 minus 8 plus 4 minus 2, negative. So this is give me nothing. F of minus 1, it will be minus 1 plus 2 minus 2, negative. So minus 1 with 1 give me nothing. F of 3, very clear, it will be 27 minus 6 minus 2, positive. So 2, f of 3 and f of 2, both are positive, give me nothing. So this is the correct answer. Do the same. 2 to the power x minus 10 over x. That will be my f of x. Check f of 2. It will be 4 minus 5. 4 minus 5, which is minus 1. This is negative. F of 3 will be what? 2 to the power 3, 8 minus 10 over 3. That is positive. So this is okay. Yeah. F of minus 2, that will be what? 2 is minus 2 plus 10 over 2, which is positive. F of minus 1, it will be 2s minus 1 plus 10, which is positive. So this will give me nothing. F of 1 will not do. F of 1 will be 2 minus 10, negative. 1 and minus 1. Minus 1, there is a problem here. Yeah. F of 1, it will be what? 2 to the power 1 minus 10, which is negative. Okay. F of minus 1, 2 is minus 1 plus 10, which is positive. So this is also an answer. So there is a problem in the question. F of 2, it will be 4 minus 5, negative. So 1 is negative, negative. So this will give us nothing. F of 4, it will be 16 minus 10 over 4, which is positive. So there is a problem. These two are correct answers. Okay. Which of the following condition will guarantee there is a root with this equation between minus 1 and 1? That he make it very complicated. That he put A and B, I want you to check. So put A minus 6, so the equation will be minus 6x squared, and A is minus 6x, and B is 6. So this is my function. And I have this minus 1 and 1. Check f of minus 1. It will be minus 4 minus 6 plus 6 plus 6. So that will be positive. Check f of 1. That will be 4 minus 6 minus 6 plus 6. So it will be negative. So this is correct. Yeah, if you check these for sure, they're not correct. And I will leave it for you. Yeah, the same idea. But it's too odd to. So I need to check 5 functions. So you need, for the second one, you need to check this function. 4x cubed minus 6x squared minus x minus x, I mean, plus 1. Let me do the second one. F of minus 1, it will be what? Minus 4 minus 6 plus 1 plus 1, negative. F of 1, it will be 4 minus 6 minus 1 plus 1, also negative. So that will not help. And you need to do the same for the rest, which is too odd. You should conclude that the two curves intersect. So it will be, I have, this is f, this is g. I need h of x, which is f minus g, because I need when f equal to g. So I take 1 to the other side. That will be what? X cubed minus x squared minus 1 minus x squared plus 3. So it will be x cubed minus 2x squared plus 2. That will be h of x. I check f of minus 1. That'll give me what? Minus 1 minus 2 plus 2, negative. H of 0, positive, so this is okay. H of minus 2 will be minus 8 minus 8 plus 2, so it's negative, so this will give me nothing. H of 1 will be what? 1 minus 2 plus 2, which is positive, so 0 and 1 will give me nothing. H of 2, that will make it bigger, that will be 8 minus 8 plus 2, positive, that give me nothing. H of 3 will be 27 minus 18 plus 2, which is positive. So this is will give me nothing. So this is the only answer. The guarantee that has a root in this interval. So this is my function. I need to check f at 0. It will be 0, 0, 0, minus 3, negative. F at 2, it will be what? 8 minus 4 plus 4 minus 3, which is positive. So this is okay. F at 1, I need to check 0 and 1. That will be 1 minus 1 plus 2 minus 3. This is negative. So 1, I need to exclude. This is 1. This is wrong. Between 0 and 1, both are negative. So I'm getting nothing. F of minus 1, it will be minus 1, minus 1, minus 2, minus 3, which is negative. So minus 1 and 1 give me nothing. F at 3, that should give me positive. 27 minus 9 plus 6 minus 3, which is positive, very clear. So this is out. Between minus 1 and 0, negative, negative. So this is also, so this is the only answer. Okay, now let me check some questions related to the, just to finish this. Yeah, this is the correct answer. By the way, this is the precise definition of the limit, which is not part of this course. If we have a g function, so that g is continuous at c, then this is continuous. No, I need f to be continuous. F should be continuous. So this is wrong. If you have g functions that the limit equal to L, can I take the limit inside? I need f to be continuous. So this is wrong. If it's continuous and this AB, f of A not equal to B, and K is any number between this and this, then there exists a number C, so that f of C equal K. I need the interval to be closed interval. So this is wrong. Function, no, I want the function to be continuous. So this is wrong too. So the correct answer is this, which is not part of this course. But then I show it so that we need to be careful about the statement of this intermediate value theorem. Yeah, this is the question where you need to be careful. You need just to sketch what's going on. A function is continuous over this interval. So between minus 3 and 6, the function is continuous. F of minus 3 is minus 1. Yeah, let me make the function is like this. And this is minus 3. And this is 6. And f of minus 3 is minus 1. And f of 6 is 3. F of 6 is 3. So I have this point, minus 3 and minus 1. Okay. And the function is continuous. The function is continuous. So if I put f of c equal 1, this is 1. For sure, I cannot combine this to this unless I cross the 1. So there is existence between minus 3 and 6. So this is correct. The other are not correct. Let me check them. F of c equals 0 for at least one c between what? Minus 1 and 3, not minus 3 and 6. Minus 3 and 6 should be correct. This is wrong. Because, yeah, if this is minus 1, so the 0 is not there. Okay. And the same thing for, yeah. So this is wrong. F of c equal 5. 5 is outside the interval. Outside this. 5 is here, so I'm not sure. Yeah, I can't combine it. Combine these two without passing by 5. So this is wrong. Because 5 is wrong. F of 0 equals 0? No. like in this graph. So very clear this is. Now this one maybe confused some of the students. No, it says what? For all x between -3 and 6, I want f of x to be always between -1 and 3. No, this is not correct. Because what will happen? Maybe the function, let me graph another function. Okay. So this is the point, and this is the point. And this is -3 and 6. This is -1 and 3. Maybe the function will do something like this. So it's not always between -1 and 3. So this is wrong. So this is the only correct answer. So you graph it and then discuss it. This is a little bit harder. You need to read the statement and be careful. It says what? The function is continuous. Let me move it a little bit here. So this is 2 and 6. Okay. And the only solution to this equation, f of x equals 7, it means if I have the line x equals 7, y equals 7, I mean, it will be crossed only at 2 and at 5. This line will be crossed only there. If f of 3, this is 3, f of 3 is 9, somewhere here. F of 3 is 9. Then it means the function will be, this is a point, this is a point, this is a point, and I don't know about the rest. But the function is continuous. So I need to connect this to this, and they cannot cross the 7, y equals 7, only across it here. It means if I need, so my point now is about f of 4. F of 4 cannot be here. It should be in this area. So f of 4 always must be greater than 7. This is correct. He said f of 4 must be less than 7. No, it's impossible to be less than 7. F of 4 must be greater than 9. No. If this is 9, if this is 9, so f of 4 can do something like this. I connect this, then I go back. So f of 4 is less than 9 in this case. So if this is wrong, it must be less than 9. No, it's not a must. I can do something like this and just continue. Then I go back to 5. So f of 4 is greater than 9. So it cannot say must be. Must be greater than 8? No, because if this is 8, I can do something like this. Now connect to this, but then I will go like this, where I am less than 8. So this is cannot say must. So this is the only solution. This is the last one, which was tricky a little bit. He put an A and B here. And he said the function is continuous. The function is very clear, it's continuous. The function is continuous on this interval. Actually, it's continuous everywhere. Non-zero constant, which the function will guarantee that has a 0 in the interval. So for sure, I need f at 0 positive and f of 1 negative, or f at 0 negative and f of 1 positive. I need one of them positive, the other one is negative. Very clear. What shall I do now? Let me discuss it one by one. Now, what is f at 0? F at 0, I have a e to the power 0 minus 0. So I have a. Okay. What is f at 1? It will be ae minus b. Okay. Now, if I put a is positive, I need this to be negative. Correct? So that means what? Because all the answers, I have E in this side. So I take it in this side. So I have AE less than B. So I have E less than B over A. Or I can say B over A greater than E. Okay. So I need to see both A positive and B over A greater than E. Where I have A positive, I don't have this. I have something wrong. So this is wrong. B over A less than E, this is wrong. So these two wrong. So I cannot have this. let me have this. F of 0 is negative, so that means A is negative. And AE minus B should be positive. Let me do the calculation. I have AE greater than B and E greater than B over A. So I can write E less than B over A, which is this answer. I can write E greater than, sorry. Yeah, I write E here. So it will be greater than B over A. B over A less than E. So this should be the answer, which is wrong. Why? Be careful here. To do this, I need to divide by A, but A is what? Negative. So that means E, I need to change the sign, less than B over A. So that means E or B over A greater than E. So this is the correct one, not this one. This is wrong, and this is wrong. So that should be my answer. Yeah. Let me stop. So mainly the question is substitute. He will give you interval and a function. Sometimes you need to be careful. You need the function to be equal to 0, and then just substitute. Okay, so let me stop the recording. This is the end of this section, 2.4. And then I will go to the next one. So I'll stop the recording. Thank you.